All right, we'll get started. Welcome everybody. I see 28 on the calls as of now. A good crowd so far today. My name is Suresh Srinivasan. I'm the coordinator of the Beginner Special Interest Group for the Minnesota Astronomical Society. We do monthly events, and what in the spring and summer and early fall, we'll be outside doing observing events. Normally they're at Metcalf Field, which is part of the Bellwin Conservancy near Afton. And over the winter, we do monthly presentations via Zoom. And this month, we've got Bob King, the astronomer extraordinaire, the jack of all trades astronomy. Uh, many amateur astronomers know Bob through his Astro Bob blog, where he posts the daily happenings and what's coming up and the like. He's one of the more prolific observers you'll find, and I know him mostly through observing. I know Bob loves comets, and he really loves the Northern Lights. He writes for Sky and Telescope, and I think he still writes for the Duluth News Tribune sometimes, right?
Hmm.
And Bob is actually an author as well. And I think about 6 months or so ago, maybe a year ago, you came out with Magnificent Aurora, which is kind of apropos for this discussion. And if people are interested in his book, you can see the link on the invite. If you don't have it, let me know. And actually, I'll just drop it in the chat for you. But with that, I'm going to hand it over to Bob King.
Thank you very much, Suresh. And just a quick thing about the book, you can purchase it from like Sky and Telescope website, but if you want a signed copy, you can just send me money through the mail or use, PayPal or whatever service, and we could work that out. You can contact me via email at Duluth Aurora, or pardon me, I'll tell you the address later. But anyway, just contact me. I'm Bob King.
So
Whoops, sorry.
let me just jump in real quick here. One thing I forgot to mention is if people have questions during this presentation, please put it in the chat. And when Bob comes up for air, with a pause, I will then ask the question for you. That's to keep Bob's flow going and keep the talk moving. All right, Bob, back to you.
Great, thanks, Suresh. And sorry, I sort of gobbledygooked that email address. It's DuluthAurora@gmail.com if you want to get in touch with me for a signed book. Anyway, let's talk about the Aurora. We did finally get some Aurora earlier this month after like a 2-month hiatus. That was back on January 3rd, and it turned into a pretty good Aurora. It lasted all night. Maybe some of you caught that in the Twin Cities area or wherever you're watching this from. Here in Duluth, it was super cold that night and windy. And of course, if you're an Aurora person, it doesn't matter. You always go out anyway because you never know what to expect. And that's what I like about the Aurora. I really don't know how many times I've seen it, hundreds, but each time I think, well, what am I going to see that's different or new? And there are always surprises with the Northern Lights. So with that, we'll start with the presentation. And we're going to talk about three different aspects of the Aurora. First, sort of getting a basic understanding of it, and then photographing it with just basic equipment. I'm going to go over using your smartphone. But if you do have camera questions, DSLR, mirrorless, feel free to ask or remind me to talk about those as well. This was, I should say, this Aurora was back in May. We had this absolutely spectacular one. This was visible all over Minnesota, and this couple in the foreground had arrived at around 1:30 that morning on May 9th. And they thought they had arrived late, but it turned out that all of the gauzy aurora just suddenly congealed right at that time, and the whole sky erupted in these massive focusing of rays overhead into a gigantic corona. This is one of the coronas. Of course, it's always pulsating and flashing, so you get one after another, after another, after another, which is why I recommend when you're photographing the aurora, two basic things, if you have a DSLR or mirrorless camera, a very wide angle lens, 10 millimeter, full frame fisheye lens really works well at f2.8. And that will capture the giganticness of what you see overhead. And then high ISO, go up to 6400 or so, and shoot for 2 to 3 seconds so you can preserve the structure of the aurora, which is rapidly changing. There's another. This was the next night, and it didn't look like anything was going to happen. And then the whole northern sky just totally lit up with these shimmering, they were literally shimmering curtains. They lit up the landscape too. If you look near the bottom of the image, you can see trees, the field, everything in there. And then yet another one. This is back in October the 7th. I was laying on the ground watching this and letting the camera do its thing. It was just one pulsating corona after another, just magnificent. And on October 6th, prior to that, prior to the big storm, we had not just the typical green colored aurora, but we had these very prominent red rays that appeared in the north and northeastern sky. So this is a very brief phase, but very, very colorful. We'll talk about what causes those colors in a moment. Of course, it all comes from the sun. Basically, the sun is sort of the switch, the instigator, the arsonist, if you will. And it is if you saw the Lion King, Pumbaa, the warthog, was correct. Our sun is a ball of burning hydrogen gas. It's 865,000 miles across, 93 million miles away. Of course, you know it's not actually gas per se, but it's so hot there that hydrogen gas, the main ingredient of the sun, has been broken apart into its component particles, electrons and protons. And those are swimming around in the tremendous heat. And that material is called a plasma. Here's the sun, so you can see it kind of in relation to the planets and how small Earth really is in comparison to it. We often look at the surface of the sun or just above the surface with our filters. We see the photosphere, invisible light, and then the chromosphere when we're using hydrogen alpha. But the corona is out there too, the sun's atmosphere. And the corona we view during total solar eclipses. Beautiful thing. And it's always active and it's always in motion because the sun is so dang hot that it's boiling off material into space all the time. And that's essentially what the solar wind is. It's material that is boiled off, blown away from the sun into space. And great enhancements in the solar wind are at the bottom of what causes the northern lights. So the Earth has its own magnetic field. The sun, I should mention, has an overall magnetic field. We'll get into sunspots in a second here. But the sun's magnetic field, which is created by molten currents of iron, liquid iron in the outer core of our planet, and it's spinning, creates this protective bubble essentially around us, and it's called our magnetosphere. The bubble is flattened in the sunward direction because the solar wind is always pushing at it and on it, and it stretches out like a comet's tail in the other direction. The whole structure, again, is called the magnetosphere. This is the front end, and this is the tail end of the magnetosphere. Now, solar activity rises and falls. You guys know this. About every 11 years, it reaches a climax, a peak, and then it drops back down, shoots back up. And it takes about a year to know when you've actually reached the peak of the sunspot cycle. There's been a lot of discussion recently, but it's happening right now. And that seems to make sense based upon the great number of sunspots and sunspot groups that are visible right now on the sun. For any solar observer, almost any time you pointed your scope at the sun to look at it in visible light, there's like 6 sunspot groups there. So it's really been fun to observe the sun. So we're at that peak or very, very close. This whole year ahead, 2025, looks like it'll be a dynamite year for solar activity, watching flares and hydrogen alpha, and also for the aurora, the northern lights. Here's a view of solar minimum. Oh, I don't want to see it. I remember the days of solar minimum when it was weeks without sunspots. That doesn't mean you don't get northern lights. It's just that they are generally less intense at the bottom of minimum and less frequent than they are when we have much more solar activity. Solar activity, height increasing means more sunspots. And sunspots are these powerfully magnetic regions on the sun. The overall solar field is rather weak, but it's concentrated in sunspots. And groups are almost like bar magnets, like the one you see here in the upper left, where one end of the sunspot group is the North Pole and the other end is the South Pole. So you've got these incredibly powerful bar magnets. You can see them on the right, the north-south arrangement. It's very clear. What happens, though, is that there's so many more thousand times more powerful than the sun's magnetic field itself, or a typical bar magnet, of course, that when they come into close proximity to each other, because sometimes you get these very complex group, but there's lots of little norths and souths, and north and south can connect, just like here in our magnet demonstration. You can maybe hear that. And when they do connect, those opposing magnetic fields, they release energy as a solar flare. That is not the only way for material to be exploded away and left and leave the sun and head out into space towards the Earth. But, oh, here's a very powerful magnet. And I'm imagining this person who demonstrated this thought those magnets would crush the apple, but instead it launched the apple. But still you can see the energy inherent in powerful magnetic fields when north and south come together. The solar flare eruption in a sunspot group, when those magnetic norths and souths connect, releases an incredible amount of energy. You get a sense of it, what's happening on the right side of your screen. 100 million or 100 megaton hydrogen bombs, which is an inconceivable for us amount of energy. And when it occurs, it can blast out some of those subatomic particles, the plasma of which the sun is composed, embedded with a magnetic field into space. So it's not just particles being sprayed out, but it's sort of bundled and wrapped in the sun's magnetic field. So there's sort of these fluctuating and swirling north and souths within this bundle of particles, which is hopefully now approaching the Earth. We call these ejections coronal mass ejections, or CMEs, and they are the source of our geomagnetic and auroral storms. They can form through flares, those types of eruptions. There are also large prominences on the sun that we see in silhouette and call them filaments. Sometimes these filaments are ejected into space. They're made up of plasma, and they can also cause a major storm here on the Earth. We're going to take a look at, very quickly, kind of a little in a nutshell view of what happens when a flare occurs on the sun and energy and particles are released in the Earth's direction. There you see it blasting off, and it's headed towards the Earth, sometimes at up to speeds of like 7 million miles an hour. There's our magnetic field trying to buff it. But in this case, most cases, that material will just blow by. But in this case, the particles and field connect into Earth's magnetic field, and they are deflected back behind the planet, and they reconnect and slingshot solar material and energy towards the Earth's polar regions where the aurora forms. So let's just, we're gonna view that one more time. I hope you don't mind. We're going to see our flare so that you can follow the material to the sun. You can see how it presses on the forward-facing part of the magnetosphere, how the particles, the solar magnetic field and material connect into Earth's magnetic bubble and then are swept back by the great wind into the tail, where they get pinched together. We have opposing magnetic fields, north-south, pinched together, releasing energy just like that apple flying, and that propels material in our magnetic bubble into the polar regions. So our Earth, again, is like a dipole magnet, and that material, those electrons and protons, solar material, flow and converge around the north and south poles of the magnet. So they follow those magnetic field lines into the upper atmosphere. They are assisted along the way by all kinds of interesting physics, which we won't get into, but they are accelerated as they move through Earth's magnetic field to like 44 million miles an hour, which is fast enough and energetic enough to actually really give some pump and power into the atoms of the atmosphere. And that's important because that's what creates the northern lights. You can see once again our filament or our iron filing demonstration here on top. So in the animation, you saw that you had two little crowns where the material was coming in and striking the atmosphere. This is an actual image taken by a satellite in ultraviolet light that shows these little crowns, and they're called ovals. There's one up in the North Polar region. That's the northern auroral oval. There's one in the bottom called the southern oval. Here's a really nice time lapse, and you get a sense of what the oval looks like as the Earth rotates over time. This is over Antarctica, so we're looking at the southern oval. So you see, what you're seeing there is the glow, the green glow from oxygen in our atmosphere as those highly accelerated particles, charged particles, strike the air and cause it to glow. One of the best analogies to the Northern Lights is, you can't find a CRT these days anymore. I can't find an old monitor where I take a tube out of it. But it really is like a cathode ray tube, a CRT, where you have an electron source, right? That's over here. And that would be the sun, or electrons that are actually just present anyway in the magnetosphere because there always is material waiting there. It's accelerated through the cathode ray tube, and it strikes a screen at the end, which is coated with a special phosphor that makes it glow when the electrons strike and excite the materials in that phosphor. Well, it's just the same way with our atmosphere. You've got the streams of electrons. They're accelerated by the magnetic field. They strike the atmosphere, and they make it glow like one big old CRT tube over our heads. Our local one, our northern oval, is sketched out here. And you can see that it's centered not on the North Pole or the North Magnetic Pole, but it's actually centered on the North Geomagnetic Pole, which happens to be located just off the coast of Greenland on Ellesmere Island in Canada, right about there. And these are some cities here which are located very close or right under that auroral oval. The oval is always present because there's always some activity happening. There's always a solar wind. The magnetosphere is always being squeezed and compressed. Energy is being transferred from the flow of the wind into the magnetosphere. So there's a flow of particles, and during solar storms, that flow really goes up. So the oval is constant. It can vary in shape and size, but during quiet times, this is where it hangs out. So if you live in Fairbanks or Churchill or Reykjavik, you will always see the northern lights as long as the sky is dark and it's clear because you're underneath this oval. The rest of us have to wait for the oval to expand, and we'll see how that happens right now. Here's the oval in a quiet time. Pardon me. The northern one, you have the night side of the Earth, there's the day side, and there's the southern oval over Antarctica. So during these quiet times, you can really only see it kind of in the Arctic, the polar regions, that ring that I showed you before. But during a solar storm, it becomes highly energized. There's lots of particles coming in. The atmosphere is really getting bombarded. And so that energy is being transferred into light, and the oval expands outward. And in the northern hemisphere, it expands equatorwards or south, which brings it down into our latitudes. And that's why we see the northern lights during big storms. We're looking here at the night or midnight side of the Earth. That's when the oval is at its greatest extent, reaches farthest to the south. And that's why you have to stay up kind of late sometimes to see the northern lights. You have to wait for that oval for the Earth, for our region, Minnesota, to actually swing under the oval. I should point out that the oval is not spinning like this. Instead, the Earth is turning and the oval is just sitting there. So on the day side, there's very little northern lights, but as we rotate into the night, we come under the oval and hit that most southern extent around the midnight hour or 1 a.m. in the summertime. Here's a little animation showing you a storm in progress. These are using images that you could pick up from the 30-minute forecast site that's put out by NOAA. You can see the expansion of the oval as the storm intensifies, as particles and that connection between the sun and our atmosphere is made and continues through the night. One of the coolest pictures, this was taken by a satellite, shows the part of the auroral oval in May during that really big storm. And you saw how the oval is normally way up there in Churchill and Fairbanks. During that huge storm, the oval expanded so far south that we in Minnesota were right under the oval. Look at this. And even in Iowa, people were under the oval. So that was one intense storm. At one point during that storm, the oval had expanded so far south that I did not see northern lights in the northern sky here in Duluth. I had to look south to see them. I saw these rays happening, across the constellation of Scorpius and Ophiuchus. And you're like, wow, this must be a big storm if I can't even see behind me, but just in front to the south. Auroras have beautiful colors, which are always very hard to see with your eye and don't get any easier as you get older. Most prominent, easiest one to see is green, because our eyes are built to be a lot more sensitive to yellow-green light, which is what the sun primarily emits, compared to red light. Red light has to be brighter and more intense before it excites the cones in our eyes. So most aurora looks like kind of a smokyish white with a faint greenish edge. But occasionally you'll see one of these really deep red rays, and it's so super exciting to see that. It's like, oh, you just, I don't know, it goes straight to the heart. What's happening when those electrons, it's primarily electrons that are creating the visible aurora. There are proton auroras. They're not as obvious, generally fainter, a little less common. But the electrons are spiraling down those multiple field lines, zillions of these electrons. They are striking the atmosphere. And when they hit an oxygen atom, they excite the atom. The electrons in the atom jump up to a higher level, and then they want to immediately relax, come back to rest. And when they do, they emit a little photon of red light. As the electrons burrow down further into the atmosphere, they create a green light. That's another excitation of oxygen. And if they keep going further, you can get purple from nitrogen. So the primary emissions of northern lights, the reds and the greens, are from two different excitation levels of oxygen atoms. And then the more secondary color in the northern lights, and harder to see, is blue from nitrogen and also purple from nitrogen, especially at the very bottoms of the rays. I'll show you a picture of that in a moment. I thought this would be a really fun animation to watch. It's very slow-mo. You have to picture this happening incredibly fast, but you can see the yellow electron. It's like a Plinko game, where the little disc goes down and hits the pegs. As it hits the pegs, as it hits the atoms, they become excited, relax, and emit light. And you get these great colors. And sometimes the colors mix too, so you can get a little bit of yellow. People have recorded orange. There's magenta is a common color in the northern lights. So there's lots to see. Of course, cameras can pick it up a lot better than you can with your eyes because you're doing a time exposure. So you can gather, stack the light over time. As far as where it happens overhead, the red aurora is the highest, generally the highest visible aurora for us. It's about twice the height of the green aurora. And all of it is below the altitude of the International Space Station. There are auroras that can get up above there a little, but the most common ones are below the space station. And you can see it with your eyes. You can actually see this physical separation in altitude on a good aurora, where the bottom will be green, it's the lower part of the atmosphere, 75 miles high, and the top will be red. Again, both caused by excited oxygen atoms. All they want to do is take a rest, and when they do, they emit those colors. This graphic shows in a little bit more detail the different states of the molecules or atoms. So just to give you an idea of where they are, that purple is kind of rare, sort of a plum color. Maybe some of you have seen it on really active auroras. You'll see the bottoms of the arcs or the rays. They'll briefly look purple, Those are from super highly energized electrons. Those guys are moving so fast, they've made it all the way down to about 60 miles high. That's about the lower limit for the aurora, low enough and still have enough energy to excite the nitrogen atoms that are very thick, relatively thick at that altitude. I have not seen many of these. Fortunately, there was one night I was out and it was mostly blue ionized nitrogen aurora. Camera picked it up very well. I have never seen blue with my eye. I cannot pick this color up. It's there, but it's much too faint to excite the cones to see it. So where can you see the aurora? Interestingly, when there's a big storm, don't head too far north. If you head up to like where the geomagnetic pole is, you won't see any aurora because it'll all be to the south of you. Here, in this location that I've marked, you would see aurora visible in your southern sky, but very little to your north. Here in central Canada, Alberta, like where the Alberta aurora chasers live, you would see aurora filling the entire sky. And then down here in the Duluth and Minneapolis area, you would look out that night and say, huh, I see rays and arcs in the north. But if I turn around, I really don't see anything happening in the south. If you're further south, Texas, Oklahoma, you're not going to see any aurora. Or you might just be able to record some red aurora with your camera. Remember, red is the highest aurora. So from your location, you might pick it up, maybe even visually. Let me just show you how that works. This is an Aurorasaurus diagram, and I altered it just a little bit. We've got two observers. We have one here in New Mexico named Celeste, and then we have Bob. Currently, I'm in North Dakota. And I can look up from my location and say, oh, yeah, I can see green. I can see red on top of that. Celeste cannot see the green because it is blocked. She's so far south, it is blocked by the curvature of the earth. So the only aurora she could see is the red. That's way the heck up there. So that's why when you have a huge aurora, you'll hear about sightings in Texas and California and even Florida. And the pictures will all be this really bloody red color because that's all they can see due to the curvature of the earth. Unless the oval expands further yet, right? If it keeps going, then perhaps they'll be able to pick up some of that green as well. I did mention this earlier. It expands farthest south around local midnight. That's why it's usually best to go out and see the aurora on either side of midnight. But you can't make any rules about the northern lights. You could say, yep, that's best. But then next time it's out, it's best during twilight. So it'll fool you. It can be very powerful at different times of night. And you can get multiple storms. You can get an evening storm, the aurora can calm, and the next morning at 3 a.m., boom, happens again. That people say, when I've gone to bed, I said, I'm heading to bed now after I post something on Facebook. And then 2 minutes later, someone say, Bob, get out there right now. I'm like, I can't, I'm too tired.
Hey, Bob,
Yes.
we have one comment and one question.
Yeah, go ahead.
Let me ask Chris Bethea asked, the red's been really prominent over the last year, even with the naked eye. And then Zenobia Evans asks, have you heard the chatter of the aurora?
Oh, the sounds? Any sounds?
That's what I think she's asking.
Yeah, and I think there's been more red too because we just had a lot more intense aurora activity. You know, we've had some powerful solar flares, monster filaments being shot off from the sun. So there's a lot of power and energy there to make those red ones happen and intensify them enough to be visible with the naked eye. As far as the other, I have never heard the aurora. I have tried and tried. And now I'm too old. You know, I don't know, but I've got the frequency ability to hear it anymore. However, I do have a device that I can listen to the aurora and it makes an amazing sound using radio energy. I have a device that picks up these low frequency, extremely low frequency radio waves during a magnetic storm. And it makes, it sounds like birds chirping, frogs croaking. But no, I'd be curious if anyone here after I'm done would like to share an experience of hearing the aurora.
Yeah, Zenobia adds to her question, I have heard it in Canada, sleeping in camping in a tent. It really is crazy.
Wow. I wish so many times that, and I've talked to a number of people that have heard them, and I say, you sure there wasn't a power line? Yeah, there's no power line. You sure there wasn't breeze? There wasn't any brush around. There was, no ice cracking at night. There have been recordings made of the aurora by a Finnish researcher. His name is Untolainen, and it is not the aurora itself because it is physically impossible to hear the actual northern lights if it's making any sound because it's too far up in the atmosphere. There's no air. There's no air to transmit that sound down to the ground. But the electric and magnetic fluctuations are could be behind the cause of sound for the northern lights, but not the lights themselves. Again, they're too far up there. So the aurora will often begin with a quiet arc. I'll be standing out there. You'll be standing out there thinking, oh man, is this going to be the one? Then the arc fades away. But if the arc brightens, if it becomes active in any way, I encourage you to stick it out. Warm up in the car if you need to, but stay there because if there's a trend of increased activity, before long, as happened on this night, we had a beautiful arc with some very lovely rays. And then the display lasted a couple of hours and then it kind of settled back. So do stay if you sense any increasing intensity of the lights. When
I
things,
do have one more
oh,
question
go
for you,
ahead.
Bob,
Yeah.
from Eric Overgard just asked. Please clarify, color is dependent on height of the photon release or atom that is involved, nitrogen versus oxygen, or both?
It's both. The atom oxygen produces green and red, and nitrogen does the blue and the purple. But the oxygen is capable of doing two different kinds of emissions depending upon altitude. At extremely high altitude, where it's really rarefied air, oxygen has enough time before it's struck by another atom, which would bleed off its energy, to emit the red light. Further down, the density of oxygen atoms is much too high. There's not enough time before an atom hits another atom for that oxygen atom to release red light. Instead, it releases green, which it can do in an instant. So it gets rid of the energy like that before it gets hit.
It's
Higher up,
shorter wavelength. Mhm.
and it's higher up, there are far fewer atoms. And so there's enough time for the oxygen. That red light takes, I want to say, about 1 minute for it to emit. Now, in 1 minute's time in the lower atmosphere, you'd get whacked by another atom and the energy would be bled out through motion, let's say, kinetic energy. But up high, there's time for that thing to go boop and shoot off a red photon. Not down low, though. Green down low, because that emission is very rapid, very quick, before another atom could strike that atom that wants to emit. Does that help to explain? So it's really both altitude and what the atom is, whether it's oxygen or nitrogen. Is that good? Are we
Uh,
still there?
Wait for the message. Yes, thank you. And then one last thing, Zenobia mentions that she's actually worked in Antarctica, and she would hear the noises from the aurora from her time in Antarctica.
And were you just out completely in the open with nothing around that would create a sound that could be used? Or what did it sound like, I should say?
Zenobia, if you want to just chime in directly, go ahead.
Yeah, feel free.
Yeah, can you hear?
Yep.
Okay, good. No, I worked in Antarctica, and we've got a science tech who did all the Earth science recordings and this, that, and the other, and she would just have a it was just recording of the aurora hitting the ionosphere, right, or whatever, and just yeah, you could hear it. I mean, you could just she might do an all call on the loudspeaker overhead, and she'd say, hey, the aurora's going, maybe during the day, right? You can't see it, but she'd get it on, and it was a good solar storm, and you could just hear the chatter. It was crazy.
I have not heard of any recordings or seen any papers about auroral sounds recorded
Huh.
in this way. Not a one. The only
Interesting.
sound, yeah, and I don't know why that is. If this really happened, this is like totally like somebody should publish this information. And
Right.
it was,
Well, I'll see. Yeah, I'll see if I can get a hold of
Zenobia's
her
gonna.
and see.
would you do
Yeah,
that?
if you could
And
send that'd be great.
yeah, I
Yeah.
mean, I've been asking people and talking to scientists, and nobody's got any aurora. No, people talk
Huh.
about hearing it. Most people don't hear it.
Right.
And the only person who's recorded it, definitive recordings, this guy in Finland, but it is not the usual sound that people report, which is like a crackling or a sizzling
Yeah.
or something.
That's what it was. That's what it was for me when I was camping, when I heard it. And it woke me up and I went outside and I swear to God, the lights looked like they were right in the trees. They were so close. It
Right.
was crazy.
Yeah, the aurora can look like it's down in the trees, but it's not possible to have aurora really much below
Yeah.
60 miles, so there's just nothing there for air. I mean, it's outer space basically. Uh,
Sure.
but yeah, if you would please contact me
Yeah, well,
and I'm wondering, was she using a an audible microphone or was
well,
she
it
recording
I mean,
radio? Was she
I think it's
recording
radio.
radio?
Radio.
Oh, she was recording radio energy. That's well
Right.
documented.
Yeah, yeah.
I thought you meant oral.
No, well, when I was camping, I heard it oral, but not
Oral, okay.
the
Yeah,
other was
that's
radio.
I've got a device where I talked about that where you can listen to it on this radio and it
Uh-huh.
is incredible. So I know exactly what you're talking about in that regard. Yes.
Okay, cool.
Bob,
Thank you.
Bob, along those same lines, back in the day, I used to tune into AM radio, and I think I used to take it all the way down. You could hear the meteor showers striking meteor striking the Earth's atmosphere. Can
Yep.
you do that with Aurora too? Can you hear the crackle on AM radio?
No, you can't hear, well, it's AM in a sense, but it's at the way at the bottom of the band. I mean, it's at 10 kilohertz, somewhere in there. It's
Okay.
really, really low. So you can't pick it up on an AM like you pick up lightning, that type of thing. And the
Yeah.
Aurora does not sound like lightning at all. It when you listen to it at that it's called ELF. You can look it up, extremely low frequency, ELF radio, also sometimes referred to as a natural radio or earth radio. It it emits at multiple wavelengths or frequencies, but at that frequency, they have a receiver that will turn it into sound. So you can hear what sounds like choruses of frogs and these swirly, whirly sounds that sort of go higher and then lower. And it is unique and it's really happening. It's the magnetic energy, the electrons zipping down those field lines that are releasing radio energy that you are hearing. It's quite otherworldly. So
So
if you
Ron
want,
Schmidt
I can
asks,
I can share I can share there's one fellow who builds these receivers and he is on eBay and his name is Steve McGreevy and his handle on eBay is VLF or I think it's VLF radio. Look him up. It's about $140. You get an antenna, you have to be away from any AC outlet, any buildings. You have to be out in the country because it also picks up the hum of AC power lines, and lights and refrigerator, everything. So if you're out in the country, it's a great device.
so Zenobia says that they had an ELF antenna down at Palmer Station.
Yes, that's wonderful. Yeah. Well, I'm
And then
glad that the person would make the announcement so everybody could hear. That's really
then
good.
Ron Schmidt asks, what frequency to hear the radio Aurora? Is this 10
I
kilohertz?
want to say, let me double check it, but it's like around 10 kilohertz. But I will check
Uh,
that. You know what? After I'm done, I will go and grab my receiver so you can see what one of these things looks like. Okay. And then I'll be able to tell you the exact frequency range. But it's called ELF, extremely low frequency, and VLF. So it's kind of overlap.
those are all
Anything
the
else?
questions we have for now. No, that's all we have. It's back to you.
Okay. So we talked about kind of the quieter auroras, but sometimes you'll get a bigger storm and you'll get multiple arcs, and then you'll start to see this great surging of rays, as what happened here in this photograph one night. And then the rays will continue to surge until they reach a point that's nearly, not quite, but nearly overhead. And that's called a corona aurora. And that is mind-blowing. Some of you have seen these corona auroras and you're like, oh my God, I think, I better change my ways or whatever. But you're struck by it because of its awesomeness and beauty and how it makes you feel about kind of where you are in the universe, which is why we do astronomy anyway. Interesting fact about this is what you're seeing here is a bit of an optical illusion. These coronal rays are actually all parallel, just the same way that when you see a meteor shower, the meteors appear to radiate from one point in the sky, say the Orionids, but in fact, they're on parallel trails. And I'm going to show it to you here just to demonstrate. If you stand in a forest of tall trees and look up, those trees appear to converge in the sky exactly like those rays. Well, we know the trees aren't all leaning in, right? They are all standing straight up and down. The rays are just the same. And the rays are amazing. They can be hundreds and hundreds of kilometers long, but very, very thin, like just meters thick. So it's a very thin curtain of light when you see those rays. Here's more of them. This is a corona that happened during a spring aurora storm. Here was some great color going on. You get the green, some red, magenta, a little bit of yellowing closer to the horizon. There are other things that happen. There's such a multitude, I can't go into them all now, of different auroral forms. And this is one of my favorites. This happens during the intensification stage of one of these storms. And all of a sudden, you'll see searchlight beams across an arc in the northern sky, and they get super bright. And they're caused by solar wind material creating eddies around the edge of the magnetosphere, which then propagate down into the upper atmosphere to create individual beacons. It's unbelievable. Here's one I never knew about. I was photographing it, and I thought, what? I detected a motion like a snake eating a rat is what I call this aurora. It's flowing from right to left, which is east to west. And I discovered later that what I was seeing was the giant undulating aurora, which has a slightly different cause. So it's just one of the many forms. Here's one I've only seen once. This is not my photo. It was taken by a Finnish photographer. It's called the Omega Aurora. Based on its shape, you can kind of see the Greek letter omega in there, that sort of W shape, a little bit upside down here, but that's another type of aurora. And probably the most famous one is Steve, which is the, we all know about Steve, and hopefully some of you have seen Steve. I remember seeing my first Steves back in the late 1980s when we used to call them proton arcs. Well, now we know they're not protons at all. They're not even really aurora as we know it. Aurora is formed by material that comes spiraling in. We call it precipitation of particles, right? This is no precipitation. This is a flowing river of superheated plasma associated with the appearance of an aurora. The thing is 5,400 degrees flowing through the atmosphere. It's so hot that what we think is happening is that it is heating up nitrogen in the atmosphere, breaking it apart and causing it to combine with oxygen to create nitric oxide. And that's what's creating this beacon of light. And it's associated with great flows of particles that come in during an aurora storm with heating of the ionosphere, but it is not created by precipitating particles. And it forms usually, I talked to somebody about this, a researcher. Nobody's seen or photographed a Steve in the morning sky yet. It typically happens in the evening, and it's south of the main aurora. So you'll see all the action in the north, let's say, and then you'll see off to the sides, can be east or west, apart south of the aurora, you see these narrow beacons. Can be on east or western parts of the sky. Here's another one. This is facing west here. Look at how narrow that is. That's a Steve. And the aurora is happening to the right over here. So,
Bob, I should probably ask,
yeah.
why are these Steves narrow beams like this, not spread out more like a normal aurora, I guess?
Well, a normal aurora is just a lot of particles coming in on a whole lot of field lines, and hitting the air and spreading. And this is more, it forms within the atmosphere itself in the ionosphere as a stream of high-speed particles. Now, what exactly causes the stream I can't tell you. It's part of auroral physics, that happens when things get really excited up there, when all of this material is arriving into the upper atmosphere. But it
So
is, I'm sorry. The
no, no.
stream, by the way,
Go
the
ahead.
stream, by the way, forms during a really good Steve. You'll see this arc start in the west. It'll go overhead and then appear in the east. It'll be a narrow band across the entire sky. What were you going to say, Suresh?
Mark Peterson asked, "Is there an online website that will display virtually real-time photos of aurora, similar to what you showed of last May's storm over the U.S.?"
Yeah, there are aurora cams all across the Arctic areas, Canada, Norway, and there's one in Minnesota, and that one is at Chickwalk, which is, I'm going to spell it for myself so I get it right, but it's operated by the University of Minnesota here in Duluth, and it's at the end of the Gunflint Trail, and there's a museum there called Chickwalk Museum, Chikwauk, and they have an aurora cam up on the roof, and it is real time, so you can check that out and know locally, sort of locally, if the aurora is happening. Here's a full-blown Steve. And it only lasted 10 minutes. Here's the Steve. Steve will generally look purplish in your camera. It does not look like the usual aurora colors because, again, what we're seeing here is excited nitrogen. And it's combining with oxygen because it's so hot and creating this purplish or mauve light. Associated with Steve is the picket fence. And we're still trying to come up with a good explanation for the picket fence. That's these parallel green rays that you'll see below or above that beautiful Steve arc. And their cause, we think it's sort of like the beams in a sense. It's like water flowing past a rock in a river. It's flowing so fast that it creates eddies, and those eddies stimulate the air, the oxygen, to glow green, as oxygen will do. Let's get above it all.
Bob,
Yes.
real quick, Bob. Greg Rutter asked, "What can you tell us about SAR arcs?"
Sorry. Well, I
SAR.
was going to include them, but I knew my talk would start to get too long if I put everything into it.
Okay.
It's a lovely question. The SAR arcs are cause they're and I wish I had a photo of them now, but they're giant red arcs that are so deep and so purely red and not bright, they're faint, that most people can't see them with the naked eye, but you can record them with your camera. Your sensor is fully capable. You do a 15, 30-second exposure, and you'll see this huge red wash, this arc in your photograph. And that's caused by a different type of precipitation that occurs in the Van Allen radiation belts. So we also have that happening too. We have the magnetosphere, you have the closer in ionosphere, and then you have the Van Allen radiation belts. And they're all players during a major display of the Northern Lights. So you can get a SAR arc, you can get a Steve, and of course the Aurora. Sorry, I didn't have a photo for you. Looking above it all, you can see here at the average altitude of the space station is like 250 miles. They get to look down at the Northern Lights. You can see it in profile there. It's very lovely. I think mostly green aurora, as you see in this. There are different levels of storms. You probably have already heard of these. They range from the G1 storm, minor. You got potential impacts on satellites, not too much. And in a G1 storm, which by the way is associated with something we're going to talk about next called KP index, G1 is associated with a KP index of magnetic activity of 5. Now here in Duluth, if we have a G1 storm, I get good aurora across the northern sky. Down in the Twin Cities area from a darker location, KP5, you might just get a little glow on the horizon and an arc. And if you go down to Texas, you get nothing. G2 storm will definitely bring it into the Twin Cities area, for instance. That's a KP6, and then it just keeps going. Most recent storm we had in October, the really big one on the 10th, that was a KP9 plus and a G5 storm. I mean, it went right to the top. And with each storm, that bombardment That movement, the fluctuations, electrical and magnetic, caused by this bombardment of charged particles can have powerful effects on power plants that aren't protected well, satellite electronics that are not hardened. So we're sort of sitting ducks in a way for, the next gigantic storm because we depend so much on electronic devices. And the sun may unseat all of that one day, in a powerful geomagnetic storm. We measure the fluctuations in Earth's magnetic field in the magnetosphere using magnetometers, and these are stationed all around Earth. That information is fed in, and based upon that, we make a forecast. They do that at the Space Weather Prediction Center in Colorado, and they put out forecasts multiple times a day that have KP indices, which is a measure of magnetic activity. If that number is high, as you saw, there's a lot going on up there, and you're going to see a pretty good northern lights. Here's one of the magnetometers there in Dead Horse on your right. We also have a couple of satellites, the Discover and the ACE satellite, the Deep Space Climate Observatory and Advanced Composition Explorer. They are located 1,000,000 miles in front of Earth and in the direction of the sun. So when the sun sends one of those big whopping clouds, threaded with that magnetic field towards the Earth, it's picked up by these two satellites and their instruments 15 minutes to 60 minutes before it actually arrives on the Earth, depending upon the speed, obviously, of that cloud. And that's most helpful for us. They measure the density of the material, its velocity, but most importantly for Aurora observers, they measure the direction of the magnetic field within the storm blast. And if the direction points south or down in relation to the plane of the solar system, good news. There's the down direction. The Earth's magnetic field emanates from the South Pole and points north. So here you have this southward pointing blast from the sun arriving at the Earth, and it connects with our magnetic field. They link, they couple, and that allows that energy and particles to enter into our magnetic domain. So that's the key. And that south pointing magnetic field is called a negative BZ. BZ denotes the direction. It can be positive, north, or it can be negative, south. You want negative. That's the good news. You can go to this site anytime, and I'll show you to get this on an app as well. But at the real-time solar wind site, if you look at the top graph, the red squiggle, this is the BZ. Up here are the positive numbers, 30, 20, 10. There's the center line, 0, minus 10, minus 20, and so on. What storm was this? On December 2nd, 2023. Look what happened. It was just sort of sitting there, not much happening, and then, wow, it dropped. It went down to minus 25. That is huge. If it goes down to minus 5, that's a very small aurora for our latitudes. If it's minus 10, I'm going to see it for sure. If it's minus 20 or 30, we're all going to see it. So this sat down there for quite some time, and that fed energy into Earth's magnetic field, into the magnetosphere, which then reconnected on the night side, slingshot those particles back towards our atmosphere. It shot back up, dropped back down. By the way, it doesn't have to just sit there in order for aurora to happen. If it suddenly shoots back up or shoots back down, that flexes the magnetosphere powerfully, and boom, it can also create aurora. Eventually, things cooled off, and we went back to a BZ of north, a positive BZ. So I've got here auroras visible in northern Minnesota when it's KP above 5. That's a G1. Big storm, KP 6 or higher. And just some examples of the approximate appearance of the oval at each different KP index. So now that I've told you that all this stuff is arriving from the sun, I'm going to tell you that the aurora isn't always caused directly. Sometimes it is, but not always by the particles that the sun blasts towards us. Much of it is already just sitting out there right now on today in the magnetosphere. There's just a ton of charged particles just sitting around. They come from our ionosphere, cosmic rays striking atoms, ionizing them. Sometimes the sun will, enrich that, during a storm, but it's the storm itself, the powerful energy, the kinetic energy, the rubbing, the squeezing of the magnetosphere that imparts the energy. So whatever is sitting around, old stuff, new arrivals, that gets squeezed in and becomes our aurora. So it's not a one for one. I need to point that out. So let's talk quickly about the app. I don't know, do any of you have this app? Suresh, do you use Space Weather Live?
I use Aurora Pro. It's somewhat similar to this. I do use it sometimes.
There are lots. Suresh is a good example that there are lots of different apps. I use this one. A lot of Aurora watchers recommended it, and it has quite a bit of depth in it. There's lots of places you can go to explore on the menu. But it's really great because it will alert you. You can set it to alert you for a threshold KP index for your area. So it's going to tell you, it'll give do a little whoop, and it'll say, hey, there's a chance of an aurora in your area. So when you first open it up, it tells you right then and there what the current KP index is. 2.5, not going to see much. Not here either. Here's where you can go with it, though. If you check out the Aurora forecast, you can see what the current BZ is. And when I did my screen grabs last night for this, it was a negative BZ. We were down to -5.5. That's a good sign. It also has an auroral oval. This is a kind of a big flat view, but you can click for more data and it will give you nice images of both the northern and southern ovals. You're also able to access the latest 3-day aurora forecast where KP indices are given. So you can look at that and at a glance go 1, 3, 1, 3. No, I really don't have to be bothered with the aurora. But if you see a 4, 5, or 6, definitely worth your time. Remember that, as in astronomy, all the times are UT. So for our time zone in the winter, you have to subtract 6 hours from that and put the date back 1. So it says January 10th here. That's actually January 9th that would be 9 till midnight. And that's the KP index, 3 at that time. It's a forecast, a prediction, not always right. You can tap the 3 bars on the settings to manage your push alerts with this app. And you can set it to alert you whenever it hits whatever your threshold is. Maybe your person's like, I'm not going out till the aurora fills the whole sky. Well, set it for KP 7 or 8 and you're good to go. I have mine set for 5. A couple of other places where you can get up-to-date information. There are the Aurora camps. I don't have a full list, but the Chickwalk one is one of them, local. I always post if there's a fair chance of seeing northern lights on my Facebook page. And then a wonderful place to go is the Great Lakes Aurora Hunters, because you've got lots of people across the whole region. And a lot of them are just crazy about the northern lights and will be out any night at any time, no matter the temperature or the wind speed. And they will photograph directly off the backs of their cameras and send a picture and a quick report so you can know right away. So if I see a high KP index, if my alert starts going bloop, I will check the details. I'll go and check the BZ on the real-time weather. I'll go to this page and see if we have any sightings yet, maybe towards the east where it's just getting dark in Michigan, where it's still light here. So I have a sense of anticipation, okay, this sounds like this is going to happen. And then I'll post something and then head out if it's clear. Finally, just a little bit about photography. I did mention it in the beginning. If you're using a DSLR or mirrorless, obviously the best bet is to open your lens all the way so that you can use the shortest possible shutter speed. to record the finest detail. If you're shooting 10 and 15-second auroras, the movement often is going to blur the detail over that time. But if you keep it to 2 or 3, it's going to look much more like you actually saw it. But people come up to me all the time with their cell phones. They're like, hey, look, I shot this the other night. And I'm like going, whoa. That's so, you're like, really? They're fully capable of doing aurora photography. This is an iPhone. You just take your phone, point it at the sky, tap the screen so it knows to focus on a star in the view, hold it steady, and as you touch the shutter button, it automatically goes into night mode and gives you a 3-second exposure. All you have to do is keep those two crosses aligned over one another, close, doesn't have to be perfect. It'll give you a crisp photo of the sky and the northern lights. And you can also do this in night mode with an Android phone too. And if you tap on your iPhone, there's a little yellow triangle at the top. If you tap that in night mode, it will open up a scale on the bottom that allows you to shoot 10-second exposures. But 10 seconds for an active aurora is actually too long of an exposure. Here's one taken with an iPhone back in May last year. Beautiful aurora. And if you really want to go nuts, get yourself a tripod bracket for your iPhone or Android and put it on and mount it. Once it's mounted, it knows it's in a stable platform and you can do up to 30-second time exposures with it. And just for a final kind of an overview of one of the reasons I find the aurora so beautiful. I mean, it just is beautiful. It doesn't need words, right? But it's beautiful in the same way that a snowflake, a single snowflake like you see here, multiplied trillions of times, can create a beautiful landscape like you see on the left, or quirky, fun things like stacking up on flower heads. So snow, the tiniest pieces added together, creates these beautiful sights for us. And in the same way, but on a much smaller scale, below microscopic, we have electrons, trillions of them, there and delivered by the sun and through other sources that combined, striking the atmosphere, create these magnificent display of lights. And it's once again proof that nature just creates these miraculous things with the simplest of, its creatures, we'll call them, electrons and snowflakes. This is just a time lapse from last spring. Very low resolution, but just to give you a sense of sometimes how rapidly the aurora moves and how it changes. And if you want to do a screen grab or whatever, I've got a few links here that you might find useful. The Oval, Space Weather Live, Real Time, and then those 2 Facebook pages. And with that, I will wrap it up. I'm sure I've gone on too long already. So I thank you very much for being here and listening.
This is great. Bob, could you put those links back up just for a second?
I sure
Your
can.
previous slide. And then I'll catch up on some of the questions we have.
Do they all show when you see them on your screen? Or they're not blocked by anything, are they?
No, we're good.
You're good. Okay, great. There they are.
Thank you. Let's see, catching up on questions here. So Greg Reuter had mentioned that he has some great photos of an SAR arc from October out in northern Washington.
Mm-hmm.
Chris Bethea mentioned that Space Weather Live is awesome and that they got to meet the creators at the Aurora Summit last year. I don't know if you or Chris want to discuss the Aurora Summit here, just to let people know what that is.
Yeah, that's great. I'm glad you were at the summit. I was there too. I remember, I love those guys. They gave a great presentation. And as a result of that presentation, I finally just bit the bullet and I got a subscription. I've been using the free version of it. So now I'm paying $10 a year. The Aurora Summit is a gathering of people who love the Aurora and who know a lot about it. I mean, they have scientists, who speak on it there as well as amateurs and every aspect you can think of. And it happens each year, sometimes in October, sometimes November. It's called the Aurora Summit. And it happens over in Washburn, Wisconsin, right by Bayfield, at the casino there, the big hotel by the casino. And if all you have to do is just go on Facebook, just type in Aurora Summit 2025, and it'll have all the information there. And they compile a list of speakers, and there's food and lodging and all the rest of it. So I really highly recommend it. It's a great way to meet up with people and learn a lot about the Northern Lights and other
Great.
things. Yeah.
Yeah. Are there any other questions or comments right now for Bob? You can speak up. You don't have to put it in the chat. You can speak directly.
Yeah, go ahead. Just speak right up.
Yeah, Christy mentioned it's the legendary Waters Casino, I think you're talking
Ah,
about.
thanks. The name escaped me. Thanks, Christy. Legendary Waters Casino. Big hotel. Can't miss it. As soon as you arrive, make a right and it's right there.
You have a bunch of thank yous, Bob, in the chat.
Oh,
Bob, I've
thank
got a
you.
question.
Thank you, guys. Thank you. But yes, go ahead.
In your career of photography, have you noticed any camera brands that are especially better at Aurora photography?
As far as I know, the most popular ones that are used and they seem to be equally good are Canon, Nikon, and Sony. And there might be other ones too, but those are the ones I see the most when people present photos. So I could highly recommend any of those. And I can recommend a mirrorless camera over a DSLR. If you're debating which to get the mirrorless. Much better for night photography. It has an electronic viewfinder. So when you look through that thing, you can see a whole lot more stars and you can see fainter auroras. So it's much easier to compose a photograph using the mirrorless camera. And don't be afraid if you're using a DSLR mirrorless to go way high on the ISO. If you see something changing fast and you want to capture that structure, you may even see something new no one's ever seen. Go up to ISO 16,000 and shoot it at a half a second or whatever it's required. People are still discovering things with cameras. There's a guy named Alan Dyer up in Canada, and he was one of the people that helped the scientists discover a horizontal flow in Steve. Like you can't really see it with your eye, but he did time lapse on it with longer time exposures, and you could see a flow. And so now these scientists, they have to figure out what's causing that. So the era of Aurora research, it's still open to amateurs, unlike some other areas, where you need some highly technical background. But with your camera and a good couple of lenses, you might be able to, who knows, participate in some of these citizen science things. I recommend, by the way, any Aurora watchers or picture takers to be sure to bookmark the Aurorasaurus site. It's like, a dinosaur, Aurorasaurus, and just look it up at one word. You'll get there. You can log in and they watch your Aurora observations and your photos. And it includes a map, a live map showing where people are sighting the Northern Lights. So you can go there too to check, hey, is anybody seeing this? And then contribute. And scientists will go there and use that data for their research. Sorry, that was a long answer, but yes.
Chris Bethea has a couple of questions. Chris, why don't you just ask them directly?
Okay. First one was I'm scrolling to it now. Okay, there's a CDN soft serve website. I was
Okay.
wondering what your thoughts are on that. I'm kind of asking some for a friend who couldn't make it today, and she wanted to know what your thoughts are on the CDN soft serve website.
What is CDN? I'm sorry, I feel ignorant here. I don't know what it is. CDN?
CDN soft serve.
And what is it?
It's an Aurora website.
Oh,
It's the Aurora Borealis forecast, soft serve news. It
oh,
says.
okay. Yeah.
I'd never heard of this either.
Yeah, that's news to me. I can tell you this, there are lots of sites and all the apps, they all basically use the same information, right? And that information is coming out of the Space Weather Prediction Center. So all of those NOAA Space Weather Prediction Center websites are like they
They're
are
all using the
the
same
initiated.
API.
That's where it all starts. And a lot of places, maybe the soft serve does too. I know there's a University of Alaska site. Maybe they have some of their own equipment, but so much of it comes out of SWPC, the NOAA. So I'm sorry, I wish I could answer. I can't.
That's fine. What are your thoughts on the 3-day forecast of auroras?
I find them useful. They do change a lot, like regular weather forecasts. You know, you'll look at it and it'll say KP of 6 between midnight and whatever, and you'll think, wow, this is going to be a great night. That's the one. You can get this by email, by the way, that forecast. You can have it just delivered to your email. And then 3 hours later, you get an updated forecast, KP 1.6. You're like, okay, nothing's going to happen. So it's a little up and down, but occasionally, man, they hit it right. So I always check the 3-day all the time, and I get it delivered. You can just go to the Space Weather Prediction Center and look for their products. And they have multiple products involving these, KP index and all kinds of things regarding the aurora and sunspots and flares too. So there's so many ways to get. Yeah.
That kind of leads into my next question on the website that we use, Space Weather Live. Do you watch the KP levels and the BZ levels and the hemispheric power? I mean, which is your first go-to when it's getting close to that time, or whether, it's a pants-on night, as they say in the forums?
As they say, yes, my KP index is usually delayed somewhat by a couple hours. So my hands-on, if you want to take away one thing from this whole talk, keep an eye on the BZ. Go to that real time or just use the app and see what the BZ is doing. It shows you where it was, so you get a sense of trend on the app. But you can go to that website I show you and follow that red squiggle. I want to be sure to mention, when you do see the squiggle drop down to say -10 or -20, you get excited, and that's good. Be aware of it. That is real-time data. So that's what the satellite just picked up. It's going to take at least 15 minutes, typically more like 45 to more than an hour, for that part of the storm to reach the Earth. Remember, it's got 1,000,000 miles to go. And then link in, wrap around the back and couple, and then send it to us. So when you see the BZ drop, you don't have to run out of the house immediately. You got about an hour before that material actually arrives, which is really a fascinating perspective when you think about it. You can picture it like a train on its way to the Earth, 1,000,000 miles away, and achieving that distance in an hour. It's incredible. It gives you a sense of the great power here involved in these events.
Bob, Ron Schmidt asks, have you had the opportunity to travel to Aurora Oval sites like Tromsø, Churchill?
Oh, that's nice. Thanks for asking. I have never been there. I've always wanted to see a polar aurora, and I will finally get my chance. I'm going to be doing I'm going to be a presenter with the Rhodes Scholar boat. Whatever, they got all these boats that they go up the coast of Norway, and in February I'm going to be on one of these boats going up the coast of Norway, up beyond the Arctic Circle. We're going to be talking about the Northern Lights, and I'm going to hope for good weather and get my first chance to see polar lights. By the way, if anyone is interested, I learned something really cool about the aurora at the summit, just in a discussion. Like here in our area, we see the aurora, we look up laterally. We see the side view of it mostly. So we see the greeny bottom and the red rayed top. When you're in the Arctic, under the oval, instead of seeing the arcs like, they do get arcs, but the aurora is more streamer-like. Those arcs are over your head, multiple parallel streamers, and you're looking up at the green bottoms. And the red tops are kind of hidden even farther up above those guys. So I've talked to people who have seen Arctic aurora, and they say, we don't see much red there. And I'm thinking, well, the Midwest is a great place after all. We do have something over the polar regions. We can see the red because our perspective is broadside rather than underneath. Does that make sense?
Yes.
Yeah.
Bob, I did find some information on the Aurora Summit. It looks like it'll be November 7th through 9th. And I put a link in the chat for people that are interested.
Oh, that's wonderful.
It's
Thank you.
theauroraSummit.com. So let's see. Any other question? I don't see anything in the chat. Any other comments? Oh, there is one more. Let me go find it. It's from Ed Solstice. You may have covered this, Bob, but how to prognosticate when and where aurora will occur.
Well, you know what? You can look at what the forecasters do is there are other, it's a tough one. There are other ways aurora comes too. You can forecast a certain kind of aurora. There's one that is created by holes in the sun's corona. They're called coronal holes, and particles just stream out at high speed. And holes can last for months. So sometimes we can actually predict and say, okay, in 27 days, whatever, there's a good chance for aurora because that hole will be pointed towards the Earth. But flares and erupting filaments and other ways that they happen in the moment. You can say with some probability, look at this sunspot group. It's magnetically really complex. Something's going to happen here. It has this type of configuration. And then boom, it happens. We get a flare. Well, first of all, is that flare material? Does it even shoot out material, or is it just a flare without releasing? Sometimes that happens. Is it shooting out towards the Earth or off to the side? And even if it's a direct hit, if the BZ of that material as it rumbles by our planet is north, it's not going to link in. There may be some types of aurora form, but no major storms. So we can get a prediction, make a forecast, but we can't really know until that material arrives at those two satellites I showed you. Till it blows by those guys, we don't really know if it's going to link in and create a major storm. So no, our prediction ability is limited.
Yeah, the anecdote I can add to that, Bob, if you remember that May 10th weekend where we had the 2 nights of the aurora,
Yeah.
I was up north. I was at Long Lake that weekend, and it ruined my deep sky imaging, by the way. The
Yeah.
aurora just filled the sky. You couldn't do anything else.
I know.
But, everybody had talked about that Friday night, and Friday night was awesome. There was less of an emphasis on Saturday. And what I thought was Saturday in some ways was actually even better because we had those I don't even know what you call them. They were like
Shimmering
streamers
curtains.
going across the sky. It was like a whip, and
Yeah.
it only lasted 20 minutes, but
Yeah.
the aurora would pulse across the sky. So
Mhm.
it'd move about 120 degrees in like a second or 2 seconds. It was just like a whip, like a crackling whip, and it
Yeah.
kept doing that for about
Yeah.
20 minutes.
Yeah.
And so, you really can't predict these things. Nobody had said that was coming. And you just have to go out and hope for the best.
One thing about those big storms, Suresh, is that when they did forecast a pretty big storm, but that one was even bigger than they expected. When it did
Exactly.
happen, we got that great display. Just as my anecdote, whenever we get a really big storm like that, the whole magnetosphere can be so rattled that even if the next day doesn't look like a great forecast, always go out because it seems like there's sort of a spillover effect into the next day and sometimes a third day after a major
Yeah.
storm. So I often just do a quick drive just to make sure and I check. But yeah, by the way, I asked, you're talking about that sharp whip-like effect. I asked an Aurora researcher just the other day, I said, what causes the sharpness of the aurora? Because I was, how some forms are really etched, they're sharp, and then they blur out. And she's checking for an answer. She was not able to answer the question.
Yeah,
And
I'd never seen anything like that. That was crazy. It was like it literally was like a pulsing effect going across the sky.
Yeah, it's like there is a charged lane and it's following the lane. It's like it appears and disappears within the same channel. It's like a lightning stroke in a sense, where it just keeps shooting through that channel. And exactly what causes that, I couldn't tell you.
Chris Bethea added in the chat the Aurorasaurus website.
Yes.
and reporting auroras from the ground up. And then she mentions that you can sign up for notifications through that site,
Yes.
mostly email, and then send a message and when to go out, and then report back if you see anything.
Yep.
And
Yeah.
then
That's the
James Peasley says the early May outbreak landed during the Messier Marathon at CGO and had a great view.
well, it's good that you were out, right? Even though
That's good. Everybody was out that
everybody's
weekend.
out, you had to abandon the Messier, some of the Messier objects, maybe, but yeah, Aurora source, and they do. I want to emphasize they do appreciate your data, and I'm glad whoever that was that brought up the fact that once you sign in to Aurora Source, you will receive all emails about anytime there's even the smallest chance of an aurora occurring in your area. It's dead on. If they have kind of a low KP threshold, the threshold for them for the Duluth region is just the faintest glow on the northern horizon. So if that happens on any nights, I get an alert overnight at some point from Aurora
You
Source.
must get that frequently. Up there.
Very free. I wake up and I go, oh, it looks like we maybe had some minor aurora. I have discovered, I've kind of researched this a little bit on my own for fun. I used to think we needed a KP index of 5 here in Duluth. And then I realized, no, I can see the aurora at 4. So I thought, what is the minimum? And I went out night after night, and I was able to see the aurora with very low, kind of that red aurora like they see in Florida and Texas. I got very low aurora, even at KP 2.5. The aurora
Wow.
is visible. So that's what gives me credence in this Aurora Source email
You
alert.
never know. You never know with Aurora.
And the thing is,
I
our dark sky is so critical to the study of the northern lights. If you need any reason at all to turn off a light, it's to preserve, for our area, it's to preserve the northern lights for us, our kids and grandkids. I mean, it is, to me, equally magnificent as a total solar eclipse. I love them both.
so I get this question a lot, Bob, and you might not be able to help since you live in Duluth. So I'll open this up to if people have a suggestion. But a lot of people ask me, where should we go to see the Northern Lights in the Twin Cities? And I don't really have a go-to place, maybe Eagle Lake Observatory. Does anybody else have a place where they go near the Twin Cities or, but say within an hour's drive that maybe has a good horizon towards the north, 24/7 access? Does anybody know of any places?
I recommend,
May I just say, I remember leaving Roseville, going west on 694 to some church in Minneapolis to give a concert. So went early for the warm up, the concert.
Hello.
I saw the Northern Lights on the way over. And then I also saw the Northern Lights coming back. So did they really stay up there for 3.5 hours?
Yes, that happens. Sometimes there are.
I'm gonna have to
go ahead.
talk to them about that.
I'm sorry, what was that? Somebody
it's
made a
extra
comment.
cash that we got, but
Somebody speaking. Hello? Maybe it was something else. A couple of places people are mentioned is Crex Meadows. The issue with Crex Meadows, it's roughly 90 miles from the Twin Cities. Laura mentioned the North Orrock Trailhead in Orrock Township. Where is that?
We are in it.
Laura, where is that? Like how far?
Orrock? How do you spell
cities?
that? Suresh, how do you spell Orrock?
Orrock. I've never heard of that place.
Okay, Orrock Township. All right.
Yeah.
One thing that for anyone who's wondering where do I go, I've heard north of White Bear Lake, just go up I-35, head towards Hinckley. But does anybody in the group use lightpollutionmap.com? Has anyone been to that website? Because
I do.
That's a good site, lightpollutionmap.com. You go there, you can zoom into your area. It's color coded for where the lights are horrible and where it's reasonably dark. You can see all the highways, so you can plan a trip to a reasonably dark area. And I always recommend for people to do this in the daytime. You can also enhance it by using Google Maps and then doing the ground view or the earth view, whatever, where you can see the roads and the trees and stuff. Then you can kind of plot a potential position to be, like maybe a parking lot somewhere where you could set up. But do your research and if possible, go there in the daytime so you can check the area to see if there's an actual place to park or if there's like that one bright light shining in a field that's going to ruin it for you. But yeah, that light
So
map is helpful.
Laura mentions the Sherburne Wildlife Refuge. I've heard good things. I've not been there myself, but I've heard good things about that place. It's
That's a nice,
about an hour and a half northwest of the Twin Cities,
that's
kind
a
of
good one.
along the path towards Long Lake from the Twin Cities on the west side. And I've heard it gets pretty dark there, but I don't know if there's a site within the refuge that's flat enough to have a good view of the north or good
There is.
horizons. Laura, have you been there?
Sherburne's really amazing, except for their park hours. They close at sunset or a half hour
Uh,
after.
Oh,
do they close the road that goes to the park building?
Close one of the roads and they will come in after you if they find you in there. Uh, I do want to say, to answer your question, use Google Maps. Find the nearest public water access that's on the south side of a lake that's near you, and that would be a good place to go find. You've got 24-hour access, you got the lake, you've got reflections for pictures. It's absolutely amazing. And Christy and I have found some magnificent locations using Google Maps and finding public water access areas on the south
great,
side of DC North.
great,
That's
great
good.
tip. Thank
That's a
you.
great tip. And I use the same here. I tell people in our area, because we have so many lakes, I say, well, just drive up this road, pull off, you got public water access. There's a parking lot there often. So, and you get a chance to shoot reflections. And that's
Are
really,
there any other questions for Bob? Any other comments? This is great, Bob. Really appreciate you doing this.
yeah, well, the questions are great. Participation is wonderful.
Yeah, I at the peak we had 44 people on the call, so it was well attended. I guess I'll chime in here about our next beginner special interest group presentation. It's scheduled for Saturday, February 8th at 1 o'clock. And Dave Faulkner will be presenting on the NASA Artemis program,
All right.
which will take us back to the moon. And then I should probably also mention the one after that is on Saturday, March March 8th. Tom Field from RSpec Spectroscopy is going to present to our group. So if you're interested in spectroscopy, that'll be a good one to attend. Again, Saturday, March 8th at 1 o'clock. Ron Schmidt asked a question. Bob, what's your favorite foreground subject when shooting Aurora?
Oh, I'm just old fashioned. I'm so focused on the Aurora. I don't think about the foregrounds a lot, but I do like myself some nice spruce trees in the foreground on occasion. And I also really enjoy, I've kind of found this nice little lake. And when it's calm, I like to be able to get that reflection off the lake, sometimes with stars if it's really, really calm. So I guess, I like a little woodland and I like that reflective lake surface. And yeah, yeah, that lake, I've spent so much time at that little lake and I've listened through all the different seasons, from quiet of winter through all the different frog species that you hear throughout the summer and early fall, the wolves, there's even cows out there somewhere. But being out at night, following the aurora means you're out in nature. So if the lights do not perform, let's say, as expected, you're just outside. And that to me is just everything almost because that always having a connection to nature makes you a happy person. That's what I believe.
Bob, do you have any places along the North Shore that you could recommend for people to go if people
Yeah,
want lakes
just
views or whatever?
there's one that's fairly close, just outside of Two Harbors. There's the Silver Cliff Creek Tunnel, that giant tunnel. As soon as you go through the tunnel, you can pull off in a parking lot right afterwards. And then there's a walkway that takes you up to the top of the hill that the tunnel's in. And from there, you can see out over Lake Superior, and you can't see directly north that well, but the northern lights often spread to the east. And so you can see the lights over Lake Superior there. And it's dark too. That's a great thing about it. Of course, once you're at that spot, you can just keep going up the North Shore, just make a left turn at any point and drive up. The road on the way to Finland, which is just, if you go past Tetegut State Park, on that road, County 1, I believe it is pull off the road. I do a lot of just road pull-offs. I find the nearest, I get off the asphalt, and I get onto a dirt road where it's quieter. And I just spend my time there. And I meet some interesting people too. When you're just out, all friendly so far.
So far. Let's see. Conrad mentions he'd like to go down to Lake Billsby down by Cannon Falls. Does anybody else have any questions or comments for Bob?
How far is that, Conrad? Where is that? Lake Billsby?
Cannon Falls is about an hour south of the Twin Cities.
So 1 hour south. Okay. You don't want to get too far south, right? You want to keep going north if you can. Does anyone ever go west into Wisconsin, just straight east into Wisconsin from the Twin Cities? Has anyone had any experience with dark skies there? No, maybe not.
It seems like once you get to Hudson, if you go north, it gets dark really fast.
I've got a pastor. This is Jim Peasley. I've got a pastor friend of mine just east of New Richmond in Forest, Wisconsin, and it's the darkest sky I've ever been at. I haven't been up to Long Lake, of course, but beautiful up there.
How far of a drive is that, Jim?
About an hour.
See, that's a reasonable amount of time. I mean, if I want a dark sky here, it's about 20 minutes to 35 minutes. So an hour, I would do an hour if I was in your situation too. Not a problem. It's a little more of a commitment, but bring some coffee, get some snacks.
Well, I think that's it. I don't see any other questions for Bob. Bob, this is awesome. Thanks for doing this. Everyone, a recording of this presentation will be posted onto the Minnesota Astronomical Society YouTube page in probably 2 or 3 days. It has to get edited and then it'll get posted up there. So if you want to see this again, feel free to do that. Thanks again for coming. Again, I counted to 44 people on this presentation. So Bob, you really know how to reel them in.
Oh, thank you so much for having me, Suresh. And you guys have been great. It's just been wonderful talking about the Northern Lights together as a group. So thank you.
Awesome. All right, guys, take care. We'll see you on February 8th at 1 o'clock.